Hello and welcome to this session on what we're calling inverse proportion. Now before you go any further, please just make sure that you have watched the session before this, which we called multiplicative scaling. If you haven't watched that session, you may find this session quite difficult to follow. Okay, so we're ready to get started. Make sure you do have some paper and a pen handy to write down useful notes and also any working that I ask you to do. So if you need to go and get that now, please do. Okay, so I've got a question for you first of all. The question is, looking at this rectangle, which has an area of 24 centimetres squared, how many different rectangles could you draw? How many different variations of the base and the height could you have to form a rectangle with an area of 24 centimetres squared? If you're confident you know what you're doing, please press pause now and have a go. I'd like you to come up with as many as you can. If you do need a bit of a hint, please keep watching and I will explain a little bit further now. Okay, so if you need a bit of a hint, I've listed 4 different lengths for the base. So what I want you to do is to work out what the height must be to make sure that area is 24 centimetres squared. So just press pause and have a go at those 4 now. Okay, let's have a look at this then. So I've got a base of 24 centimetres and I know that the area of the rectangle is calculated by multiplying together base and height. So if I've already got a base of 24 and I need an area of 24 centimetres squared, my height must be 1 because 24 times 1 is 24. For the second one, I've got a base of 12. What do I need to multiply 12 by to get 24? I need to multiply it by 2. The third one, I've got 6 centimetres for the base. What do I need to multiply that by to get 24 centimetres squared? I need to multiply it by 4, so that must be the height. And then finally, I have a base of 3 centimetres. So in order to get 24 centimetres squared, I need to multiply that by 8. So the height there must be 8 centimetres. Now, I just want you to take a moment and think about what's happening with the base every time. So press pause now and just think about what you observe there. Okay, what I hope you spotted is this. So I'm going from 24 to 12. I've halved it, I've divided by 2. Going from 12 to 6, I've halved it again. Going from 6 to 3, I've halved it again. Now I want you to focus on the height. So what's actually happening to the height each time then? The base changes. So press pause now and just have a quick think about that. All right then, so I'm going from 1 to 2 centimetres initially, so I've multiplied by 2. From 2 to 4 centimetres, I've multiplied by 2. From 4 to 8 centimetres, I've multiplied by 2. So bearing that in mind, could you predict what will happen when the base is 1.5 centimetres based on what we've observed? If you want to have a go at this, press pause and have a go now. Okay, so hopefully you've seen I've carried on with the trend. So I divided 3 by 2 to get 1.5. That means that I need to continue the same pattern for the height. So I need to multiply my height times 2 to get 16 centimetres. Well done if you got that. So how we can summarise this is to say that as the length of the base halves, the height doubles. The length of the height doubles. And if you look at the base times the height in each row, 24 times 1 gives us 24. 12 times 2 gives us 24. 6 times 4 gives us 24, and so on. Multiplying the base by the height must always give us 24. Then we know we have a rectangle with the same area. Now this is an example of an inversely proportional relationship, and that's what we're going to define next. Okay then, so now you will need a pen and paper because I'd like you to write down some key things, please. So in the last session, we talked about the fact that values are proportional when there is some kind of relationship between each pair of values. Now we're ready to get a bit more detailed with that now and to start to think about this in a slightly more specific and mathematical way. So what you saw last time was that values are directly proportional when two variables change at the same rate and in the same direction. So for example, as one increases, so does the other one. And we saw an example of this with recipes in the last session. So we needed to increase or decrease the ingredients by the same multiplier to make sure that they're all in the same proportion so that the recipe works. Okay, we can also say that values are inversely proportional when two variables change at the same rate but in opposite directions. Therefore, as one increases, the other decreases. So we've just seen that the height of our rectangle increases and the base of our rectangle decreases in order to keep the same area. Now, what I'd like you to do, please, is to press pause and write down those two sentences, please. So the turquoise text is what you need to note down, and the pink text is the key terms. So you might want to underline those key terms. So press pause now. Okay, good. And one final point before we look at a slightly different example is that relative simple proportion questions, they probably won't even mention the word proportion, and that's certainly the case with the example I'm just about to take you through. Okay, so let's look at this example then. So we're told that it takes one person 24 days to dig a hole. And what we want to know is how long it would take 2 people, 3 people, 4 people, and then 48 people. So just using that one piece of information, I'm going to work out how long it takes these amounts of people. So what I'm going to start with is a table. So I've got number of people on the left-hand side, and I've listed there 1 person, 2, 3, 4, and 48. And I'm told that it takes 1 person 24 days. So I've put that in there as well. So now what I need to look at is what's happening with the values in the left-hand column. So let's just look at the first couple of values then. So going from 1 to 2, I am doubling, which means the number of days must halve. So 24 divided by 2 is 12. And hopefully that makes sense because you would expect 2 people to take less time than 1 person. Now we are making an assumption here. We are assuming that those 2 people work at exactly the same rate. Okay, let's look at 3 people then. Now I'm going to go back to the number of people being 1. And I'm going to look at what's happened. So I've gone from 1 to 3. So I've multiplied by 3. So going to the number of days, I need to divide 24 by 3 to give me the correct number of days for 3 people. And that's 8. So whatever I'm doing on the left-hand side, I am doing the opposite on the right-hand side. So I'm multiplying on the left-hand side and I'm dividing on the right-hand side by the same value. Okay, next one. I'm now looking at 4 people. So going back to 1 to 4, I've multiplied by 4. So I go back to my 24 and I know that I must divide that by 4 because I'm doing the opposite thing, which gives me 6. And then finally, going from 1 person to 48 people, I've multiplied by 48. So what I now need to do with 24 is divide that by 48, and that gives me 0.5. So I'm saying it would take 48 people half a day to dig that hole. I'm also assuming the hole is the same size in each scenario. Now, you might also notice similarities here with the rectangle question. You hopefully will notice that each row multiplies to give you 24. So 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24, and 48 times 0.5 is 24. That's a really good check of your calculations, because if your relationships are all in proportion to each other, then multiplying column 1 by column 2 will give you the same answer every time. Okay, Now, if you want a bit of a challenge, I wonder if you can see a more efficient way to work out the time taken for 4 people and 48 people, thinking about what we calculated previously. So if you want to have a little think about this, please press pause now and have a go at that. Okay then, so thinking about 4 people. So what you could have done, given that you've already worked out how long it takes 2 people, you could have then said, all right then, I know that 2 is a factor of 4 and I multiply it by 2 to get 4. So I could also divide the number of days it takes 2 people by to get the number of days it takes 4 people. So I look across, 12 divided by 2 is 6, which is the same answer I got referring back to the top row. And then for 48 people, you've got a couple of options here, but I think the quickest way would be, once you've calculated 4 people, you could then multiply 4 by 12 to get 48. Therefore, you would divide the number of days by 12, and 6 divided by 12 is 0.5 or a half. And that's possibly slightly easier to see than 24 divided by 48. However, it's always absolutely fine to keep referring back to the value for one person. It's a little bit like the unitary method that we talked about in the previous session, but always look for efficient ways to do things. So in summary then here, as the number of people doubles, the amount of time halves. Therefore, we can say in slightly more mathematical language that the number of people is inversely proportional to the amount of time taken. That means as the number of people goes up, the time taken goes down at the same rate. Okay, so now you're ready to apply this to some practice questions. So it might be a really good idea to go to the practice video now while it's still fresh in your mind. Until next time, thank you.